You are given exactly 60 seconds to answer this question. If you're done with your answers, you can skip the timer and proceed to the discussion portion to verify whether your answers are correct or not. If you may, you can share your answers as a comment in the comment section below. If you need more time, you can pause this video in any moment you want. Your 60 seconds starts now. As you can see, all of the denominators for the given arcs here are the same. We have 4. The hint here is we don't need to memorize the coordinates of these arcs. Simply remember the simplest form, which is actually pi over 4 here. But first, let's illustrate that here on our unit circle. This again considered to be unit circle because the distance of any point on this circle from the center is equal to 1. Now, pi over 4, we already have a video of this, you might want to review on that, has a specific coordinate, and we discussed it with specific concepts that allowed us to identify the correct coordinates of the special arc. But in terms of degrees, this is actually 45 degrees. Okay, so 45 degrees is somewhere here, like that here. Okay, so this is the point or the terminal point for the pi over 4 arc, and take note we're moving counterclockwise because it's a positive pi over 4. Okay, if we have positive arcs, we're going to move from here and move counterclockwise. Okay, so this has x and y components, and as we had before, okay, you might want to review that video, specific video. Just simply automatically give this one here. You might memorize this, but just familiarize yourselves. You don't need to memorize the rest as soon as you would know the coordinates of this. We have square root of 2 over 2 and square root of 2 over 2. This is the coordinate of our pi over 4. And this would be the same figures for all the rest of the given here. I'm telling you right now. I'm gonna claim it right now. All the same figures, but they might differ on the signs. So let's proceed to the second. I'm going to illustrate that using the second. We have 3 pi over 4. The coordinate of 3 pi over 4 will be greatly understood by identifying its location on our unit circle. Take note that a semicircle is pi. If you're going to divide this by 4, you will also have a division here. So you have 1, this is your 2, this is your 3, this is your 4 in terms of divisor of 4. In short, your 3 pi over 4 is here. 1, 2, 3. This is your terminal point for your 3 pi over 4. What does this tell us? The location of our 3 pi over 4 is on quadrant 2. Okay, it can be found in quadrant 2. What does this imply? We just simply copy this. Okay, we simply copy the same coordinates, square root of 2 over 2, square root of 2 over 2. Because our denominator here is 4 and we have 4, simply copy that. What would be the change here is that you need to look at the sign of x and y in this specific quadrant, quadrant 2. On quadrant 2, our x is actually negative and our y is still positive. Hence, this is the coordinate of 3 pi fourths. See, we have the same figure, just different signs because of its location. So same will go through with the other two here. Okay, we will have the same figures as we go on. So we can claim it right now that the coordinates of negative, okay, even if it's negative, we're going to illustrate it anyway. We have the same figures. Square root of 2 over 2. This is not yet the final answer. Okay, don't worry. Square root of 2 over 2. We have the same figures here. But we'll be completing that after we are going to identify the location of negative pi fourths. Take note that the arc is negative. So instead of moving counterclockwise, we're going to move clockwise. And this is our negative pi, right? If we are going to divide that into 4 parts, here's the division. So this is our negative pi over fourths. Only one movement. Negative pi over fourths. So we have this as our terminal point for negative pi over fourths. Now, at which quadrant is this? Or which one is it located? We can locate negative pi fourths on quadrant 4. And on quadrant 4, x is still positive, but y now is negative. See? We just simply change the sign because of its location. Next, we have the coordinate of negative 7 pi over 4. Okay? So negative 7 pi over 4 is also a negative, but we can safely say that the figures here again is square root of 2 over 2, square root of 2 over 2. Simply change the signs when necessary. So negative. So we have here 1. We're moving clockwise. 2. This is 2 here. 3. 4. Continue. 5. 6. 7. Okay? Yet see this coming, but surprisingly, this has the same terminal point as pi over 4. Okay? And of course, this is found on the first quadrant. Hence, x and y are both positives. So basically, they are the same. They have the same terminal point. This is what we call as coterminal angles or coterminal arcs. This might not be part of this video, but advanced understanding. Coterminal arcs are arcs of the same terminal point. And if we have coterminal arcs, we have the same coordinates. It just so happened here that I have given you examples of coterminal, already coterminals. But nevertheless, 1, 2, 3, 4, 5, 6, 7, this is its terminal point, same as pi over 4. Since these two are coterminal, let's add one more. How about negative, just simply positive. Positive 5 pi over 4. So it's positive, so we're going to move counterclockwise. But then again, let's try to write square root of 2 over 2 and square root of 2 over 2 here. Okay? So we're going to move counterclockwise. 1, because it's positive. 2, 3, 4, 5. The terminal point is on the third quadrant. And what are the signs of our x and y on the third quadrant? Both are negative. See? We have the same figures, but different signs depending on the location of the terminal point. So you don't need to memorize all of this. Simply try to remember the simplest, pi over 4, and the movement of arcs if it's positive and negative, and the location of the quadrant, so that you could alter the correct signs, or give the correct signs and alter those signs that are incorrect when it comes to your terminal points. Thank you for watching.